Homeostasis, blood calcium. Remember, homeostasis is a state the body is trying to achieve, a state of balance to optimize function. And this image here we have is representing high blood calcium. Now you could say hypercalcemia, but remember the body does, in our example, the body does have the tools to adjust for it. So if you do say hypercalcemia, recognize that your hyper means more calcium, but this is a state that's going to be adjusted. So let's say we have hypercalcemia or high blood calcium. What happens is there's cells in the thyroid, and notice the butterfly shaped looking gland, the thyroid, remember that? And this is the isthmus that joins the two lobes of the thyroid, that's isthmus. There's cells in there called clear cells or parafollicular cells. And those cells are going to produce a chemical called calcitonin. Calcitonin. And when I hear that, I hear the IN, and then that reminds me, oh, calcium into the bone. Calcium into the bone. And that's what happens. This chemical is released from the clear cells of parafollicular cells of the thyroid, and that stimulates osteoblast, blast build, osteoblast, these cells to deposit it into bone, deposit calcium into bone. And I have an image of a child here because this action is more prevalent in children. So, or more active in children. Children have more clear cells than adults do, or parafollicular cells. They actually decline as we age in adults. Now over here, notice how I moved the calcium down to the bottom image. This is low calcium. We could call this hypocalcemia, hypo meaning low. But again, remember referring to a state in which the body has the tools to adjust for it. So, and I put it in red because you need calcium for muscle and nerve function. So, and if someone's experiencing hypocalcemia for too long, the heart won't work. So the heart's a muscle, right? It needs to contract. So, it's very important that the body does have the tools to adjust for it. So hypocalcemia, low blood calcium. On the back side of the thyroid, on the posterior aspect, are the parathyroid glands. Parathyroid, P-A-R-A. And these are these four little glands here. And they'll release a hormone called parathormone. And I use this image. This kind of looks like a bone is being demineralized here. And that's what happens. They'll release this hormone called parathormone, and it'll activate what's called osteoclast. These cells clast crush, and they'll break down the bone. And we call that resorption, like reabsorbing. And there's this little resorption bay where this ruffled border is working. Also, what they'll do, they'll cause the kidneys to excrete means to get rid of, phosphate, because you don't want calcium and phosphate to bind, forming hydroxyapatite. You don't want that to happen. So, because we want the calcium to be in the blood, so to bring it back up to normal level. So let's take a look at the notes. So high blood calcium causes the thyroid clear cells or parafollicular cells to release calcitonin, which causes osteoblast to build bone. Blast, build. And again, it's more active in children as they're growing. Now here in the bones are remodeling. Now here, low blood calcium causes the parathyroid glands to release parathormone, stimulating osteoclast to resorb bone. Clast, crush, break down. And it also stimulates the kidneys to excrete phosphate, so hydroxyapatite isn't being formed. Now let's take a look without the notes. Can you do it without the notes? And again, you can always pause my videos and then, when you get to that screen, and see if you can do it without notes. High blood calcium, hypercalcemia, cause the parafollicular cells or clear cells of the thyroid gland to produce calcitonin. Calcitonin stimulates osteoblast to build bone. And again, more active in children. Now just thought of it, you could also just turn the volume down, right? As I go through the arrow and see if you can fill in the words yourself. Low blood calcium stimulates the parathyroid glands to release parathormone, which stimulates osteoclast, crush, to break down bone, put that calcium back in the blood to bring it back up. It also causes the kidneys to excrete phosphate so that hydroxyapatite isn't formed. Thanks for joining me today.